It's easy to create digital signal sequences with the word generator. The word generator is one of our many instruments available on the far right. Go ahead and place that. I'm going to zoom in just a bit. And I'm actually using my scroll wheel at the moment to finish that off. Now we have the least significant bits going all the way up to the most significant bit. I'd like to see the least significant showing up on the right side, so we can do a quick horizontal flip there. Let's take a look at what we've got. There's actually lots of different options for this. I'm just going to set up one simple example here. We'll go ahead with binary display, internal triggering. I'll set a buffer size of 16 elements. And for decimal, maybe that's a little bit easier way of doing this. 16 actual elements. If I switch that back to hex, 10 hex is actually what you'd have to type in that way. I'll use an up counter sequence, and here we see a traditional ascending binary pattern running from all zeros to all ones, and then it repeats. Let's use the 4-channel oscilloscope to take a look at the lower 4 bits. In case you don't already have the virtual toolbar enabled, that's how you do it. Right-click and pick virtual. I need to connect my scope ground, and then I will connect my 4 binary signals. Did a little bit of stop motion magic there. Of course, it takes a little bit longer to get the wires connected and color coded. All right, we see it stepping through. We see the 4 traces emerging on the oscilloscope. I'm going to adjust the Y position on each of these traces, making each one distinct in its own space on the oscilloscope. Main point here is just to get them separated so they're easy to see. Here we see the least significant bit going the fastest and the most significant bit going the slowest. Now if you experiment with the cursors, you notice that the voltage at the low value is 1/2 volt, and for the high value it's 4.5 volts. These numbers are hardwired into the word generator. You cannot change these voltages. In many cases, these voltages may not be suitable for your particular circuit. Here's how you can solve that problem. Select all groups, select all families, and do a search on the Abm Voltage Source. Abm is an abbreviation for Analog Behavioral Modeling. This voltage source can be set up to essentially sense, so to speak, another net in the circuit and then apply an operation to that. So to make this easy, I need to come up with a series of named nets. I'll call this one the word generator bit 0. And repeat that same operation for the remaining 4 lines here. And again, quick stop magic, and we have all 4 of these labeled. Incidentally, you don't necessarily have to have them attached to any equipment. You could just have a dangling wire sticking out like that. Once you have a named net, then type the value or the string that looks like this. I'll say if the voltage of the net called WG0 is greater than 2.5 volts, that's more or less midway between 0.5 and 4.5, then the voltage should be 10. If that's not the case, then the voltage should be negative 10. And of course, you can specify any values that you like. I'm just using 10 and minus 10 as an example here. Let's fire up the second oscilloscope if I can find it. And we'll use that to take a look at the ABM source. Alright, that's looking good. We see that at 5 volts per division, we have a maximum value of 10 and a minimum value minus 10.